This is third video on projections of lines inclined to both the reference planes. Unless you watch earlier two videos, don't watch this video because you will not understand properly the method used here to solve problems. It will be wastage of time. Okay, now read this problem. Line AB 140 millimeters long, so true length is 140 millimeter, is inclined to HP by 40 degrees. So theta is given 40 degrees and its front view is inclined to XY line by 65 degrees. Listen, clearly it is mentioned that front view of the line is inclined to XY line by 65 degrees. Now what is that notation we use for inclination of front view of line? So alpha. So alpha is given 65 degrees. Its end A is 20 millimeters above HP and 20 millimeters in front of VP. So let's write that data here. This horizontal line indicates XY line and 20 millimeters above HP. So measure 20 millimeters above XY line and front view gives distance from HP. So that is A dash. That is A dash. And 20 millimeters in front of VP. So measure 20 millimeters in front of XY line. And it is distance from VP, so top view gives that distance. Draw projections of the line and find its inclination with VP. If you remember in earlier lecture, I told you that if a line is inclined to both the reference planes, then minimum information you should have is this 5 measurable details. Minimum 5 measurable details are required to draw projections of a line which is inclined to both the reference planes. So let's proceed. Here it is XY line. Draw projector of the reference point. Mark the reference point. Now through all labeled points we draw horizontal vertical lines, and when we draw horizontal and vertical line, you will be always knowing which is the other point on that line. So horizontal line through A dash, we know that on this line it is B2 dash, and through A there is a horizontal line, and we know that on this line it is B1. Now through A dash there are 3 front views. Okay. Now listen, there are 6 views finally will be there in our drawing. Which 6 views? AB, AB1, AB2, A dash B dash, A dash B1 dash, A dash B2 dash. So AB has length PL and angle beta. AB1 has length PL and it is always parallel to XY line. That is why we are sure that on this horizontal line B1 is. AB2 is true length and has true inclination. It is top view, no dash here. That means it is top view. It is true length top view. So true length top view gives true inclination with VP. 5. A dash B dash has length EL angle alpha. A dash B1 dash has length true length angle theta. Top view carrying suffix 2, top view with suffix 2 is true length top view, and front view with suffix 1 is true length front view. Okay, and true length always gives true inclination. A dash B2 dash is EL parallel to XY line. It is horizontal view, and that is why we are sure that on this horizontal line B2 dash, because A dash B2 dash is always horizontal. Now what is our procedure? As I told you, using data out of these 6 views, the views which we can draw, we should draw it. Using these 6 views, we must be able to bring all those measurements on paper. So check what information we have and then decide which are the views which we will able to draw. Now true length and theta, watch here, true length and theta given. That means we can draw A dash B1 dash. Also alpha is given. But still we cannot draw A dash B dash because we don't know EL. So directly by measurement we will able to draw A dash B1 dash. But one more thing, even if we can't draw A dash B dash directly here right now, angle is given alpha. So we can at least measure this angle to draw a line at an angle alpha on which A dash B dash is. You will understand. Check here. Through A dash, now I have measured 40 degrees theta, but wait, when you measure these angles, you will have to take care of position of the other end. The other end is end B. Is there any information about position of end B? In which quadrant end B is? You will have to take care of that. And if you read the problem, line AB 140 millimeter long is inclined to HP by 40 degrees and its front view is inclined to XY line by 65 degrees. Its end is 20 millimeter above HP, 20 millimeter in front of VP. Draw projections of the line and find its inclination with VP. Find its inclination with VP means you are asked to find phi. But nowhere in the problem it is mentioned in which quadrant end B is. Remember, if not given, you assume end B, the other end, in first quadrant. So it's our assumption that end B is in first quadrant. And if end B is in first quadrant, then front view above, top view below. Front view above, top view below. And that is why we are measuring 40 degrees upwards. Now, if front view above and top view below, you should measure front view angles upwards and top view angles downwards. So phi and beta, these are top view angles to be measured downwards. Alpha and theta are front view angles to be measured upwards. Right now I am drawing A dash B1 dash. So A dash is here. So at A dash you measure that angle 40 degrees and draw A dash B1 dash. What is length A dash B1 dash? 140 millimeters. So we have measured length 140 millimeters and prompt labeling. Immediate labeling is very important. So I have labeled this point as B1 dash. Then alpha is given. So measure that alpha. Alpha is angle for A dash B dash. So A dash is here. Measure that angle alpha 65 degrees and draw a line. But we cannot mark B dash because length A dash B dash is unknown. Here length A dash B1 dash was given 140 millimeter. It is true length. But length A dash B dash is EL and EL is not given. So we cannot mark B dash here. But we'll mention here that this is the line on which B dash is. Now all 5 measurements are in our drawing. Have you realized that? So this is step 1 in solving problems on lines inclined to both the reference planes. And what is that step 1? Using this 6 view logic, bring all measurements on paper. Out of those 6 views, draw the views which you can draw directly by measurements. So this is how we have brought all 5 measurements on paper, and out of 6 views, view A dash B1 dash we could draw. Remember now, if angle is known, say alpha or beta or theta or phi, but corresponding length is unknown. Of course, in this case true length is given, but length EL was unknown. In that case, you draw simply a line at that angle and label in this manner which other point on that line. Okay. Now, how to proceed? So simple. Draw horizontal vertical lines through all labeled points and rotate either EL or PL. It's that simple. But remember also that when you draw horizontal vertical line from a labeled point, you will be always knowing which other point on that line. So we'll draw horizontal line through B1 dash. We know that on this horizontal line point B dash is. B dash and B1 dash lie on a horizontal line. Is there any other line for B dash? Yes, this line. So we have found out B dash. So A dash B dash of course must be dark line. So front view of line AB we have already found out. Now we'll draw vertical lines. Remember, unless there are horizontal and vertical lines through all labeled points, don't use compass. Don't rotate EL, PL. Okay. So through B1 dash vertical line. Which other point on this line? B1. And this is the horizontal line on which B1 is. So we got B1. So remove that rough label. Now through B dash vertical line. Which other point on this line? B. Remember, there is nowhere we have drawn any line for point B. So just draw a long line B and say that on this line point B is. Okay. Now watch carefully the diagram. there are horizontal vertical lines through all labeled points. Check here, through B1 dash horizontal vertical line, through B1 horizontal vertical line, through A dash, through all labeled points there are horizontal vertical lines. That means we should rotate EL or PL. Now watch the diagram carefully. AB1 is PL and A dash B dash is EL. Rotate either EL or PL. Now A dash B dash, if you rotate A dash B dash, which other view has length EL? A dash B2 dash, which is horizontal. Remember, there are two ELs and one true length in the front view. A dash B dash, A dash B1 dash and A dash B2 dash. So A dash B2 dash has length EL. So we can rotate EL about, of course, A dash, so that you will get B2 dash here. Or PL we can rotate. But when we rotate PL, AB1, which other view has same length PL? AB. Is there any line for point B? Yes, this vertical line on which point B is. So we can rotate AB so that we'll get point B here. Okay, but according to our procedure, we rotate either EL or PL, not both views unnecessarily. When you rotate EL or PL, when you use compass to rotate EL or PL, you get a new point. Through that new point, you draw horizontal vertical lines. And if required, you use again the compass to rotate PL or EL. Let's proceed now. In this case, I am going to rotate PL. How much it is to be rotated? To get point B on this vertical line. Now, can we rotate in anti-clockwise direction? So remember, it all depends on position of the other end. If you rotate PL in clockwise manner, you will get B here, that is below XY line. B is on this line. So on this line, we can mark B above XY line also. If you rotate AB1 in anti-clockwise direction, you will get B above XY line. But it's clear that we want B below XY line. So we should rotate in clockwise manner so that we'll get B below XY line. So this is how I have marked B. Have you realized when you use compass, you get a new point. Now leave the compass. Through the new point, draw horizontal vertical lines. What I have told you, that unless there are horizontal vertical lines through all labeled points, you must not use compass. So leave the compass. Through B, now I am going to draw horizontal line, but join AB, it is top view of the line. Through B, horizontal line. Which other point on this line? B2. B and B2 always lie on a horizontal line. So this is the line on which B2 is. Now there are horizontal vertical lines through all labeled points. So again I'll use compass to rotate EL or PL, but rotation of PL is already over. And we have found out that AB. So both PLs are there in the diagram. So we'll rotate EL now. So EL, front view A dash B dash is there in the diagram. So use compass, rotate about point A dash so that we'll get A dash B2 dash. Which other view has same length EL? A dash B2 dash. Now through B2 dash, now leave compass because we got a new point again. Through B2 dash, draw vertical line. So here we'll get B2, erase that B2 and join AB2. AB2, top view carrying suffix 2 is true length. So here it is true length. Our drawing is complete. How will you come to know that your drawing is complete? You will find that in your drawing there are 6 views, 3 front views and 3 top views. So check A dash B dash, A dash B1 dash, A dash B2 dash, AB1, AB2 and AB. B dash and B1 dash on a horizontal line, B and B2 on a horizontal line. So drawing is complete. Now what about position of the other end? First quadrant, check here, B dash is above XY line, B is below XY line. So this is complete drawing. Now listen, you are also asked to find inclination of line with VP. That you are going to just measure it. Inclination of line with VP means phi. Which view gives that true inclination of line with VP? So AB2, true length, and listen, A dash B1 dash has true length and theta angle. AB2 is true length top view, and that gives inclination with VP. Top view gives inclination with VP, and only true length gives true inclination. So you are going to measure that angle phi here. Don't write a numerical value here of phi, because we have not used angle phi to construct this diagram. So remember, in your drawing only given dimensions are to be inserted. So 20, 20, 45 degrees, 65 degrees, check here, 20, 20, 65 degrees, 40 degrees, and 140 millimeter true length that we prefer writing outside the diagram. And you measure this angle phi and write a numerical value outside the diagram. Don't insert that 45 degrees angle here. When you construct this diagram to the scale and measure this angle will be 45 degrees. Read this problem. Front view of line AB 80 millimeter long. Let's write data immediately. True length is 80. EL, that is front view length, is 60. Theta is 30 degrees. Watch here. Front view of line AB. Read this problem. The front view of line AB 80 millimeters long. Check here. It's not mentioned that line AB 80 millimeters long. Clear. It is very clear. Front view of line AB is 80 millimeters long. That means, okay, read the problem. The front view of line AB 80 millimeter long measures 60 millimeter. Read statement carefully. The front view of line AB 80 millimeters long measures 60 millimeter. So line AB 80 millimeter long and its front view measures 60 millimeter. So true length is 80. EL is 60 millimeters. Its end A is 15 millimeter in front of VP and 10 millimeters above HP. So that is the reference point. End B is in third quadrant, means top view above, front view below. Draw projections of the line if it is inclined to HP by 30 degrees. This is theta given. Find its inclination with VP, that is phi you are asked to find out. So theta is 30 degrees, inclined to HP by 30 degrees, and one reference point is there. 15 in front of VP and 10 above HP. This is XY line, projector of the reference point. 10 above HP, front view gives distance from HP, so it is A dash, and 15 in front of VP. Top view gives distance from VP, so this is top view of point A. And what about the other end? End B is in third quadrant. Third quadrant means top view above, front view below. While measuring the angles, you are going to take care of this. Theta 30 degrees. Theta is a front view angle. So you are going to measure this angle downwards so that you get B dash below XY line. So draw XY line and mark the reference point. So through A dash draw horizontal line. Which other point on this line? B2 dash. Through A you draw horizontal line. Which other point on this line? B1. And now, what is first step in solving problems on lines inclined to both the reference planes? Remember, there will be 5 measurements given. Bring those measurements on paper using 6 views logic. So PQ, PQ1, PQ2, P dash Q dash, P dash Q1 dash and P dash Q2 dash. These are the 6 views. PQ has length PL and beta, PQ1 has length PL and it is horizontal, PQ2 has true length. Top view with suffix 2 is true length gives true angle. P dash Q dash, EL and alpha, P dash Q1 dash, front view with suffix 1 is true length view. And P dash Q2 dash is horizontal EL. EL parallel to XY line. Now what is the procedure? Using this 6 views logic, bring those all 5 measurements on paper. And out of 6 views, the views which you will able to draw, you should complete by measurement only. Of course, finally, by proper construction, you will be having all 6 views in your drawing. But using data, the views which you will able to draw, you try to draw first. So check what is that data. We can draw P dash Q2 dash, because to draw P dash Q2 dash, only EL is required and EL is given. And then true length and theta given. Watch here, true length and theta. So we can draw P dash Q1 dash. So this is how we'll draw these 2 views. and remaining all views, for example PQ2, true length is known but phi is unknown, so we cannot draw it. So these views will not able to draw. The views which we'll able to draw, we should draw. So let's draw P dash Q2 dash. In this case, of course, we can say A dash B2 dash. So let's draw A dash B2 dash. So here it is A dash, and we want front view of the other end below XY line. So A dash B1 dash, 80 millimeter long line at an angle 30 degrees, because that is angle theta, and label immediately this end B1 dash. Also we can draw P dash Q2 dash, because to draw P dash Q2 dash only EL is required. EL is 60. So draw A dash B2 dash. What length you have measured here? EL means 60 millimeters. So this point is B2 dash. Erase the rough label. So we got B2 dash. So this is that first step is over. After this, horizontal vertical lines and a rotation of the views. No measurements are required, because all required measurements are over here in our drawing. Now simply construction lines. So let's draw that. Through B1 dash, horizontal line. Which other point on this line? B dash. Through B1 dash, vertical line. Which other point on that line? B1. Top view of the same point. Here it is front view. So top view of the same point, that is B1 dash. So when you draw vertical line through B1 dash, okay. So through B1 dash, vertical line. Which other point on that line? Of course B1, front view, top view on same vertical line. So for B1, there is already one more line in our drawing. This is the line on which B1 is. So this is how we have found out B1. So AB1 is PL. Don't use compass right now, because there is one more labeled points through which there is horizontal line but no vertical line. Through B2 dash, we'll draw vertical line. Which other point on that line? B2. B2 dash and B2, front view and top view of the same point. Now why I have drawn that B2 upwards? Because we know that B is in third quadrant, so top view above. That is why unnecessarily don't extend that line downwards. So I have extended this line upwards, and on this line B2 is. So I'll just label this line as the line on which point B2 is. So now there are horizontal vertical lines through all labeled points. Check once again. Be sure that there are horizontal vertical lines through all labeled points, and then use compass to rotate either EL or PL. Now listen to me very carefully. Actually in this drawing, AB1 is not available for rotation. You cannot rotate AB1. What do I mean? Try to understand. Which other view has same length PL? AB. So you should rotate AB1 to find point B. Is there any horizontal or vertical line in the diagram on which point B is? Check. This is the line on which B dash is. This is the line on which B2 is. There is no line on which point B is. So how much you should rotate AB1? You will complete a circle, but you will not get point B. So this is what we say, that AB1 right now is not available for rotation. So you will have to rotate EL. Which other view has length EL? A dash, B dash. Is there any other line for B dash? Yes, here is line for B dash. So we'll rotate EL up to this line. So let's do that. Okay. So here it is B dash. So erase that rough label, because we have found out B dash. We have used compass. We got a new point. Now leave compass and through B dash draw vertical line for B. B is above XY line. That's why I've extended that line upwards. But when you draw this line, it intersects many other lines in the drawing, but we are not confused, because this line is not line for B. It is A dash B2 dash. This is XY line. Nowhere it is mentioned that B is on XY line. So just label this line as line for B. Somewhere on this line point B is, because we know B and B dash are on same vertical line. Now check once again, in this drawing there are horizontal vertical lines through all labeled points. Now use compass again to rotate either EL or PL. Of course this is our procedure, that we use compass and rotate either EL or PL. But rotation of EL is already over. Now we'll have to rotate PL. B. Which other view has length PL? AB. Is there any line for B? Yes. So now rotate AB1 PL to get B on that line. So here it is point B. Join AB, join A dash B dash. Is your drawing complete? No, not yet, because there must be all three front views and all three top views. Check here through point A, AB, AB1 and AB2 is missing. So let's continue. What is our procedure? Through B, horizontal line. Because when you use compass and rotate PL, you get one more point. So through that point, draw horizontal line for B2. B and B2 on same horizontal line, and there is already one vertical line for B2. On that line, mark B2. Now join AB2. This is true length AB2. And true length gives true inclination. Check here. You are asked to find inclination of line with VP. Only true length gives true inclination. Now here all lines are intersecting each other. But how will you come to know which top view is showing true length? AB2. Labels help you. So prompt labeling is very important in solving problems on lines, otherwise you will get totally confused. Now this is phi. Measure that phi, it will be 41 degrees. True length always we write outside the drawing. And all other dimensions 30 degrees, 10, 15 we have inserted in the diagram. But all given dimensions you will have to insert. EL 60, nowhere we have mentioned that EL. So EL is 60 millimeters. Now read this problem. Line PQ 90 millimeter long has its top view inclined to V. Let's write data immediately. Line PQ 90 millimeter long. So true length is 90. Has its top view inclined to VP by 50 degrees. Top view inclination. What is that notation we use? Beta. Its end P is 10 millimeter in front of VP and 20 millimeter above HP. 10 millimeter in front of VP. Top view gives distance from VP. So I measured 10 millimeter in front of XY line. And 20 millimeters above HP. So 20 millimeters above XY line you measure and get P dash. Okay, what else is given? Its end Q is in the third quadrant. That means top view above, front view below. Yet distances or exact position of Q and Q dash we don't know, that's why I made circle, but at least we are sure that top view above and front view below. Draw projections of the line if it is inclined to VP by 30 degrees. Line is inclined to VP by 30 degrees, that is phi given in this problem. So phi is 30 degrees. So true length is given, beta is given, that is top view inclination, and this is true length top view inclination. Both are top view inclinations, and the other end is in third quadrant. So top view angle to be measured upwards. So both these angles we are going to measure upwards. So let's proceed. Draw XY line. Now projector of the reference point. Then mark reference point. Measure these dimensions to the scale here carefully and mark the reference point. Now horizontal line through P dash. Which other point on that line? Q2 dash. P dash Q2 dash is always horizontal. Horizontal line through P. Which other point on that line? Q1. Now 6 views. PQ, PQ1, PQ2, P dash Q dash, P dash Q1 dash, P dash Q2 dash. PQ has length PL angle beta. PQ1 has length PL. It is horizontal. That is why we say that on this horizontal line Q1 is. PQ2 has true length and angle phi. P dash Q dash has length EL angle alpha. P dash Q1 dash has length true length angle theta, and P dash Q2 dash has length EL and it is parallel to XY line. Now check what we can draw. True length and phi given. True length and phi given means we can draw PQ2. And also angle beta is given. Angle beta is involved here, but still we cannot draw PQ because PL is unknown, beta is known. So in that case, at least we can measure this angle beta at point P. Also, Q is in the third quadrant and both are these top view angles. So top view angles to be measured upwards. So at point P, we'll measure these two angles upward. So okay, let's proceed. So at point P, true length and phi is given. So I could draw PQ2. PQ2 has true length and angle phi. And beta is angle of top view, that is angle of line PQ. So measure that angle 50 degrees here at point P again. But since length of PQ, PL is not given, that is why I have just labeled this line as line on which Q is. And let's proceed. Through Q2 horizontal line. So you will get Q. So PQ is ready. PQ is dark line and that is PL. Now through Q2 vertical line, it meets horizontal line here. It is Q2 dash. Q2 and Q2 dash and same vertical line. And when you draw vertical line through Q2, tell yourself immediately which other point on that line, so that you can locate that Q2 dash on this line correctly. Length P dash Q2 dash is EL. Unless you are sure that there are horizontal vertical line through all labeled points, don't use compass. So still there is no vertical line through Q. Now which other point on this line? Q dash. Q dash is below XY line, but there is no other line in our drawing on which Q dash is. So simply draw a vertical line and label in this manner to remind us that this is the line on which Q dash is. Okay. Now there are horizontal vertical lines through all labeled points. So use P dash Q2 dash EL and rotate it. So this is how you got Q dash. Leave compass immediately because you got new point. So through this Q dash, now you should draw horizontal line. Which other point on this line? Q1 dash. Now join P dash and Q dash. Right. Is your drawing complete? Not yet. All three views, all three front views and all three top views must be there in the diagram. So there are horizontal vertical lines through all labeled points. In that case, we should use compass. Rotation of EL is already over. Now we will rotate PL. Which other view has same length PL? PQ1. Q1 is on this line. PQ1 is horizontal. So make this PL now horizontal. Okay. So here it is Q1. Now leave compass through new point you got. So through that point horizontal vertical line. Horizontal line is already there. Now we'll draw vertical line. So here it is Q1 dash. Now join P dash Q1 dash and that is true length. P dash Q1 dash has true length and true inclination with HP, that is theta. So here is that angle theta. We have not used angle theta in construction. We have used only these dimensions for the construction. So you must not insert angle theta in the diagram, write it outside the diagram. Is this drawing complete? You can always check whether your drawing is complete. There must be 3 top views and 3 front views. Check here through point P, 3 top views, PQ, PQ2 and PQ1. Q and Q2 on a horizontal line. Through P dash there are 3 front views, P dash Q2 dash, P dash Q1 dash and P dash Q dash. Q dash and Q1 dash are on the same horizontal line. So drawing is complete. Q is in 3rd quadrant. Check top view above, front view below. So perfect. Now insert all dimensions 20, 10, 50 degrees, 30 degrees and true length we should write outside the diagram. And you are also asked to find inclination with HP, that is theta. So label it in the diagram, measure it and write outside the diagram this way. So if you draw this diagram to the scale, you will get that angle theta. So in this video, we have solved some more problems on projections of lines, little different problems, but there are variety of problems. So I'll dedicate some more videos for variety of problems on projections of lines. We'll meet in our next video. Thank you.